Okay, not for the exam. He asks very good questions.
He's very good.
I didn't know that. I didn't have such dragon questions actually. So maybe it's not
Okay. I think we've covered all this, more or less. Maybe we look at this a little bit. Test problems. Well, of course you can look at my solutions yourself. Would you like to discuss anything of this now? Yeah. Yeah. Would you like to discuss anything? Any questions?
I think we could do this.
Yeah.
We deal with this as well, but there was also a question of exam balance.
Oh yeah.
Which is
representing the balance in the exam. I forgot that one. Yeah. Okay. So I still have to make the exam, as you know, but I'm going to work like this. I will certainly take this list, yeah, and try to cover a few topics, not necessarily all topics. In particular, in the hyperbolic department, to just be one question, of course. So, well, I've already emphasized many times what I think is really, really important. Let's look at the previous exam for the balance between.
Is there a previous second exam?
I don't know. Maybe I.
Oral, wasn't it?
No, there is an older exam about the second part, but I made it unavailable because that year I emphasized different topics. You see, so that would give you probably not give you the right impression. But let's look at the first exam. Where is it? Here it is. No? Here it is.
It's the first one, actually.
Yeah? I know. Okay. So let's look at it. Last time I had 26 yes or no questions. The first question this year in the second exam will also be a question like this, yes or no. For example, I think I could easily ask this notion. Is it projective or not? That notion. Is it affine or not?
Yeah.
Yeah? It's easy to test knowledge and very easy to check. Okay. Last time this was 26 points max. And in total 35, 44, 44, 52, 59.
Half. Lower half.
More or less.
Yeah, about 45% or so. Yeah. Okay. So, at most, I'd say about 40% or so. Or maybe a bit less, I don't know. And then, well, I make something like this. This is the Dutch version. I make a test matrix. So here I had only 6 main themes. Now I have specified it in greater detail. So I make main themes like this. And I try to match questions to problems to themes. Here are the weights. And then I look at the weights in the first version. I'm not really satisfied because something has too high a weight or too low a weight. Change things a bit. Then reproduction, a bit more thinking, or a lot more thinking. So what's the ratio? It's about 50-50, yeah? Okay. So that's the way I'm going to. Proceed.
And in the previous exam, you could really recognize the 6 themes.
Yeah.
And you stated them on the site, on the website as well.
Yeah.
On Blackboard. And for this, one way of
You would like to have
hyperbolic and not
course
hyperbolic.
classification then.
Now, that was my question I had already in the
I'll do that.
to,
So I have to do this anyway, I think.
You have to match them.
So when I made this list about 2 weeks ago or so, I just went through. If I just only use my memory, the list would be quite shorter. So I just went through all the
slides.
all the PowerPoints, and then we covered quite a lot of stuff. So now, what's the main? What's kind of the main classification? It's projective hyperbolic. Let's run through it. Yeah? Then projective. The main classification, I think, the main subdivision is linear stuff, quadratic stuff. Yeah, I think that covers it quite well. Well, you can heap quite a lot of stuff together. For example, Desargues and Pappos are both linear theorems. They don't involve conics. Yeah. So, I could say that too. Question number 1 will be a true or false question. Question number 2 will probably be a linear question, because I think linear stuff is easier than quadratic stuff. So quadratic stuff will be question number 3 or 4. Yeah. Question number 5 will be hyperbolic geometry, I guess. Yeah. So let's think. So question number 2 will probably be something linear, and then have you prove something, for example, maybe using homogeneous coordinates, dualize a statement. When we are dualizing, I cannot ask anything about conics because we didn't cover this combination. Yeah. So I cannot ask that. And most certainly I will have a statement, maybe a linear statement, maybe a statement involving a conic, maybe a statement involving a cross ratio, harmonic quadruples, and tell you, well, take this minus the line to infinity, formulate the Fi theorem. Then maybe I will ask you to prove a theorem like that. And then, of course, I will take a theorem where you reduce properly. You can say, now we have reduced into this special situation, and now it's trivial.
For example, if you...
It's about time for a hyperbolic question, I think.
Well, if we have worked with Pappos, and then there was the choice of 4 suitable points.
Mm-hmm.
And if you choose the wrong ones, then you explode more or less, instead of that it collapses. So I guess we have to practice with choosing the right suitable points.
Yeah. But usually it's pretty obvious what you have to do. For example, if you take Desargues, try to do things symmetrically. If you have Desargues, you have these 2 triangles which are in perspective from a point. Well, I have point 0, 1, 1, no, 1, 0, 0, 0, 1, 0, 0, 0, 1. They belong together. So they are, of course, the vertices of a triangle. Obviously, you take the same triangle. You do not take 2 points on one triangle and 1 point on the other triangle. It would be silly. And then you have 1, 1, 1 for a special point. Of course, you choose this point where those lines come together. Things usually pretty obvious what to choose. And other choices aren't wrong. Maybe it's not.
It doesn't make sense.
Yeah. Okay. So last time it took me too much time to grade the exam. It took me 5 days. So I will try very hard to make an exam which is Great. Quicker.
Let's take some more shots.
Well, one way to do that is to ask only dragon questions, of course. It's very easy to do.
Make it all yes.
Or too difficult, not to complicate.
Yeah. Okay, so I think linear quadratic is a nice subdivision. Let's look at the linear stuff. Quadratic stuff is more fun, of course, but let's look at linear stuff, the more basic stuff. Well, what are then the main themes? Well, I'm just thinking aloud now, so I don't know whether we should make a final list. It's kind of mind map now. Homogeneous coordinates, duality, cross ratio transformations, something like that. And you've covered everything, I think. Yeah? Is there anything which doesn't fit into that picture? No, there isn't.
That would be a nice exam question.
No. 2 points. Okay. And then the quadratic stuff. It's this thing we have been practicing a few times. Is this statement affine or projective? Or if you have an affine statement, what's the corresponding projective statement? Prove it by choosing a smart line at infinity. Reduce it to as simple a case as possible. Usually a circle. Also, yeah. So, for example, yeah, okay. Yeah, but you can. So we had this question before when we were looking at this. Suppose you say this is a theorem about ellipses. But then you can say, well, I have a statement, it has an affine condition. But all the other stuff in the theorem is projective. Yeah? So, I don't know how to say it, but that means at least it's a very good idea to check whether maybe it's possible if you make a projective assumption. Yeah? And then as soon as you've done that, you don't get claim that it's true or false. You just look at the statement. Yeah? If you say, well, I take the same statement, but instead of ellipse, I say conic. Interesting conic. 2 advantages. 1, it's more general. 2, it's probably easier to prove. And then if you try about thinking about proving it, then you can say, well, I choose a line which doesn't pass through the conic, and then it becomes a theorem about an ellipse. So you see it's equivalent to the original theorem. So you can go both directions. Oh yeah, very good question again. Thank you very much. So glad you mentioned this.
It does have to be also
this document here. Yeah. Boundary parallel. I uploaded it last week, I think. Can we see a date or not? Last week, I discussed the proof of this Newton's theorem. You remember? And then I got a few questions. How about other parallelograms? And I showed you in GeoGebra. And someone said, well, you claim it's obvious for circles, but I'm cleverer than you are. For me, it's even obvious for ellipses. So I worked that out to show you that this is not so terribly obvious. But also, in this document, I changed the direction. So during the lecture and in this other document, changing perspective,